Hello, Pratibha College of Commerce and Computer Studies organizes a certificate course in Basics of Statistics structured by Department of Statistics. This course contains 5 modules from which I, Professor Ragini Chavan, conducting Module 1, that is Measures of Central Tendency. Main objective behind this course is to familiarize beneficiary with the concept of basics of statistics and the method to measure them in manually as well as in our software. Beneficiaries of this course are undergraduate, postgraduate students, researcher, industrialists, and government employees. After completing this course, beneficiary will able to understand and calculate the measures of central tendency, to understand and calculate measures of dispersion, and to understand and calculate the correlation between two variables, fit the simple linear regression line, and the procedure of descriptive statistics and correlation and regression in R software. Objective of the Model 1, that is measures of central tendency, are to understand and calculate measures of central tendency, differentiate between the mean, median, and mode of the data, determine the value of mean, median, and mode for grouped and for ungrouped data. These are the contents of this Model 1. So let us start with measures of central tendency. Meaning of central tendency. Measures of central tendency is a combination of two words, that is measure and central tendency. Measure means method to find it, and central tendency means average value of any statistical series. Thus we can say that central tendency means the method of finding out the central value of a statistical series of quantitative information. Uses of central tendency: to find one single figure to describe whole of data. Generally, it is used to find out a single representative value which is the central part of the given series of data. Thus, it can be said that an average or central tendency is a single figure that is computed from a given distribution to give a central idea about the entire series. The value of average always lies between the maximum and minimum value in the series. Now, which are the measures of central tendency? We can see that measures of central tendency are available in two different kinds. One is mathematical average and another one is positional average. In mathematical average, we are having arithmetic mean, geometric mean, and harmonic mean. And in positional average, we are having median and mode. So let us start one by one. First measure is arithmetic mean. Mean, more precisely arithmetic mean, is the average of some data points. It is the simplest measure of central tendency that takes the sum of all the observations and divide that sum by number of observations. Shortly, it is indicated by A dot M or X bar notation. Now let us see how to find out mean for different kinds of data. In statistics, basically data is available in three different forms. First form is called as raw data or individual observation. Second form is discrete frequency distribution, and the third form is continuous frequency distribution. So we'll see how to find out arithmetic mean for these three different kinds of data. So we'll start with raw data. In raw data, individual observations are given, x1, x2, xn. So to get mean, we need to add all the observations and divide it by number of observations. So it is summation of xi upon small n. Small n is indicating sample size. So it gives us mean for raw data or for individual observations. For example, a cricketer's score in 5 one-day matches are as follows. So this is the scores in different matches. To find his average score in a match, we calculate the arithmetic mean of data using mean formula. So the mean formula is sum of all observations divided by number of observations. So we need to add all the values of these given observations. So that values sum is coming 165 and total number of observations are 5. So therefore mean value is coming 33. So the mean score in the match is coming 33. Now this is the second kind of data, that is discrete frequency distribution. It is also called as ungrouped data. To find out mean for such a kind of data, formula is summation of fi xi upon summation of fi. Now, how to calculate mean for such a kind of data? We need to copy all xi values in the one column, then all frequencies values in the second column. Then we need to find out third column as f into x, that is multiplication of each frequency with xi values. Okay, so that is giving us summation of fi xi, and the frequencies total is summation of f. For example, we can see this is the discrete frequency distribution or ungrouped data. In that we are having data in the form of xi's and fi's. Xi's values are from 4, 6 to 15 and frequencies are given for corresponding value of x. So to calculate arithmetic mean for this data, we need to add one more column, which is product of xi fi. So we need to calculate it for every pair of xi fi. So that xi fi total is coming 360. So by the formula, it is summation of fi xi upon summation of fi. Therefore, it is 360 divided by summation of fi is coming 40. So therefore, mean in this case is coming 9. So this is the second type of data. For this, we have to add one column, that is xi fi. Now, the third type of data is continuous frequency distribution, or it is also called as group frequency distribution. In this, data is available in the form of classes and frequencies. So we'll see the example. The following table indicates the data on the number of patients visiting a hospital in a particular month. Find the average number of patients visiting the hospital in a day. So the first column, which contains number of patients, it is divided into different classes, that is 0 to 10 patients, 10 to 20 patients, and number of days visiting hospitals, that is the corresponding frequencies. So the class 0 to 10 is having frequency 2, class 10 to 20 having frequency 6. So this kind of data is called as continuous frequency distribution. Now to find out arithmetic mean for this data, first we have to calculate class mark, or it is also called as mid values. Mid values of corresponding classes. The formula to find out this class mark is lower limit plus upper limit divided by 2. So we have to find out this class mark for every class and indicate it as xi values. So to find out this mean for this continuous data, we need to find out class mark as a xi, then copy frequency fi in the second column, and again add one more column, which is product of xi fi. And then finally take total of this xi fi column and total of frequency column and divide it. So the formula is remains same of discrete frequency distribution, which is summation of xi fi upon summation of fi. So it is coming 860 divided by 30. So the mean is coming 28.67. Now after getting all the formulae of mean for different kind of data, it is necessary to understand different properties of arithmetic mean. So first property is, if x bar is the arithmetic mean of n observations, then x1 minus x bar plus x2 minus x bar plus up to xn minus x bar is equals to 0. That means summation of all xi's minus x bar is coming 0. That means if we subtract arithmetic mean from every observation and if we take total of that, it is always coming 0. So that is the meaning of first property. If we subtract arithmetic mean from every observation, then total of these deviation, that is xi minus x bar, is coming 0 in that case. Now the second property, the mean of n observations is x bar. If each observation is increased by p, then mean of the new observation is x bar plus p. That means suppose we are having certain observations and if we add one particular number in every observation, then in that case mean will change. It is coming x bar plus p. Similarly, we are having property 3 as, if the mean of n observations is x bar and if each observation is decreased by p, then mean of new observation is also decreased by p and it is coming x bar minus p. So p is indicating one of the constant number, that is the constant number which we are adding and subtracting from every observation, and it is changing value of arithmetic mean. This property 2 and 3 is called as change of origin property. Change of origin means in that we are either adding or subtracting one of the constant from every observation, and due to that value of arithmetic mean is going to change. So that is the change of origin property. Now property 4, the mean of n observation is x bar. If each observation is multiplied by non-zero number p, then mean of new observation is p into x bar. So finally, final mean is also multiplied by that constant. And property 5, the mean of n observation is x bar. If each observation is divided by non-zero number p, then mean of new observation is coming x bar by p. So the same way like property 2 and 3, here in property 4 and 5, in the fourth property we are multiplying by non-zero number p, and in property 5 x bar, that is mean, is divided by non-zero number p. So it is also changing the value of mean. So property 4 and 5 combinedly are called as property 4 and 5 combinedly called as effect of change of scale. Effect of change of scale means if we multiply or divide by certain constant to the if we multiply or divide by certain constant to every observation, whether it is changing its value or not. So here we can say that arithmetic mean is changed by changing origin as well as by changing scale. Now sixth property, that is combined mean property. Combined arithmetic mean can be computed if we know the mean and number of atoms in each group of data. Let's suppose we are having two groups having means x1 bar and x2 bar, and corresponding number of observations are small n1 and n2. So in that case, combined mean formula is coming n1 x1 bar plus n2 x2 bar upon n1 plus n2. And suppose we are having three different series of observation. So in that case, combined mean formula is n1 x1 bar plus n2 x2 bar plus n3 x3 bar upon n1 plus n2 plus N3. So basically this combined mean is used when we are having more than one series of observation. Now next property, property number 7, which is weighted mean. The weighted mean for given set of non-negative data values as x1 to xn with non-negative weights w1 to wn can be derived from the formula given below. So x1, x2, xn are the observations and wi is indicating corresponding weights. So the formula for weighted mean is w1 x1 plus w2 x2 plus up to wn xn upon summation of all wi's. A weighted average is used when we consider some data values to be more important than other values, and so we want them to contribute more to find out the average. So basically this is the main use of weighted mean when particular figure is having more importance than remaining values. Now we'll see applications of arithmetic mean. In business, mean is used to compare the average daily sales of a product between any 2 months like January and February. Suppose I have a group of 10 people, however, I want to have a height to compare them. I can add all of these heights together and divide it by 10. This gives me the average height of the corresponding class. We do all kinds of averages in our daily life. We ask friends about average house rent in their neighborhoods. We calculate monthly expenses before moving to a new city. The mean is often used in research, academics, and in sports. When you watch a baseball game and you see the players batting average, that number represents the total number of hits divided by the number of times at bat. In other words, that number is nothing but arithmetic mean. Now, that was the part related to the arithmetic mean. Now we'll move to the next measure of central tendency, that is median, which is positional average. The median of the middlemost observation, median is nothing but middlemost observation obtained after arranging the data in ascending order. For example, suppose we are having data values as 44632. So to find out median for such a kind of data, we need to arrange all the observation in ascending order first and then mark the corresponding middle value. That value is nothing but median of that data. So we can see in figure 2, 3, 4, 4 and 6. So middle observation is 4. Therefore, median of the corresponding data is 4. Now let us see how to find out median for first type of data, that is for raw data. Very first step is to arrange the data in ascending or in descending order, and then let the number of observation, that is small n, is even or odd. According to that, there are two different formulas to find out median. If number of observations are odd, in that case the formula is n plus 1 by 2th observation. And if number of observations are even, in that case median formula is n by 2th observation plus n by 2 plus 1th observation divided by 2. So to find out median, it is necessary to check whether number of observations are even or odd. Let us see the first example. In that, number of observations are given as an odd number, that is 7 observations are given. So in that case, median is comes out to be n plus 1 by 2th observation. Therefore, it is 7 plus 1 by 2. So it is comes out to be 4th observation. So 4th observation is 54. So that observation we have to consider after arranging data in ascending order, not from the original data. So very important step that we have to arrange data in ascending order and consider that ascending order to find out median. Next example, in that number of observations are even. So in that case, we have to find out n by 2 and n by 2 plus 1th observation. So number of observations are 6. Therefore, n by 2 is 6 by 2 is third observation. So the median will be third observation plus fourth observation, that is n by 2 plus 1th observation is coming fourth observation divided by 2. So the third observation is 43 and fourth observation is 50. So it is 43 plus 50 by 2. So median is coming 46.5. Now, next type of data is continuous frequency distribution. When data is continuous and in the form of frequency distribution, the median is found in the following steps. First, we need to find out median class. To find out this median class, we have to find out the quantity n by 2, where this capital N is indicating summation of frequencies. Small n is indicating sample size and capital N is indicating summation of frequencies. So very first step to find out median for this kind of data, that find out the quantity n by 2. Then afterwards find out less than cumulative frequencies. Okay, and the formula for this median is L plus n by 2 minus C upon F into H, where L is indicating lower limit of the median class, C is cumulative frequency of the previous class of median class, F is the frequency of median class, H is the class size, that is class width we can say. So if we found out all these figure and put it in the formula, we'll get value of median. We'll see the example. So this is the continuous frequency distribution is given, classes and frequencies. Now to find out median, we need to find out cumulative frequencies. Cumulative frequencies are obtained by adding frequencies. That means first frequency is copied as it is over here. That is first frequency is 2, that is copied in the cumulative frequency, and then to get next cumulative frequency we need to add all the frequencies. So it becomes 2 plus 12, 14, then 14 plus next frequency is 22, so it is 36, then 36 plus next frequency is 8, so it is coming 44. Okay, so like this we need to find out all the cumulative frequencies and then the quantity n by 2. So n by 2 is the 50 by 2 is comes out to be 25. So by this number we can find out median class. Median class is the class for which less than cumulative frequency is first time greater. So in this cumulative frequency, we can see that 36 number, 36 frequency is first time greater than 25 number. 25 is n by 2 value. So 36 is first time greater than 25. So the corresponding class is called as median class. So 20 to 30 is becoming median class. And we have to utilize this median class to find out median. So for this, L is 20, lower limit of the median class is 20, frequency of the median class is 22, C is 14, that is cumulative frequency of previous class of median class. It should be previous class, not median class. And then H is the class width. Class width is the difference between upper and lower limit. So it is coming 30 minus 20. So it is coming 10 in this case. So we have all the values of median formula. So we put that and we'll get the value of median as 25. So in this way we can find out median for group frequency distribution. Now when median is preferred. If we consider any diverse group of observations, we might prefer the median to the mean. For example, with 10,000 people, the mean salary might be 45,000, but the range is 20,000 to 3 million with the mean of 100,000. In this situation, outliers have drastically affect the mean. The few people that earn a lot of money have destroyed the overall average. It is better to get halfway point, that is, it is better to find median for such a kind of data. Let us see applications of median. Choosing the appropriate movie type. Suppose you and your family members go to watch a movie and there are three different kinds of movie available like animated movies, thriller movies and biopic movies. Animated are preferred by kids, thriller preferred by teenage group and biopic preferred by adults. And the ages of people who have visited are 6, 13, 15, 17 and 16. If you calculate the mean or the average for the following data, it comes out to be 22, which belong to the adult age group. So you have an option of biopic movie. But in the theater, you will find only one person to be enjoying it, while the other will get bored. The better alternative in such a case is to calculate the median instead of calculating the mean. The median is the middle value of the properly arranged data, that is 15 in this case. When you decide to watch a thriller movie, more people enjoy the cinema day out. The next time you can apply the concept of median to decide which movie you should watch. Next application is grouping data. Suppose you have to organize an activity in your class for which you are supposed to divide the students of the class in two groups, but you can't decide how to proceed. To do so, you should first decide the factor according to which you want the grouping to be done. For example, let the factor chosen is the height of the students. Now just note down the height of all the students and arrange the data in ascending order. Let the data be arranged as 152 centimeter, 158, 160, 162, 189 and 195 centimeter. If you calculate the median of the above mentioned data, it comes out to be 161 centimeter. Now two groups can be formed very easily. One would be a group of students with height above 161 centimeter, while the second group has a height below 161 centimeter. Next application is explicating the poverty line. One of the prime applications of the concept of the median lies in the calculation of the poverty line. Let us suppose we have the information about the monthly income of different groups of people in the following range. That is 1,000, 2,000, 3,000, 30,000 and 80,000. The mean comes out to be rupees 2,300 23,500. If someone employs the concept of mean to set the poverty line, it would be highly inappropriate. This is why we jump to another notion, that is median. The median of the above data comes out to be rupees 3,000, which can more accurately decide that the people below this benchmark are poverty ridden. Next application is buying a property. Buying a property is a particular decision in one's life. Assume that you visit a broker who deals in real estate. He shows you pictures of various houses with their respective prices, like 30 lakhs, 32 lakhs, and up to 95 lakhs. You ask him for the average price, to which he replies rupees 60 lakh. Average is coming 60 lakh. Also, you observe that the median price is comes out to be 40 lakhs because the middlemost observation is 40 lakh. In this case, you may easily get trapped in the difficulties that the houses with lesser prices might have some flaws in them, while the expensive ones go out of the budget that have planned. When you consider all the factors, you tend to go with the house worth middle or median price, that is 40 lakh, and that proves to be the wise decision. Hence, you may consider taking the help of the median while choosing an appropriate property to invest in. Next application is home budget. We all tend to plan a monthly budget irrespective of whether we follow it or not. Suppose every month you spend rupees 700 on personal care, rupees 100 to pay the water bill, rupees 800 on snacks, rupees 500 to pay the electricity bill, and rupees 6000 to pay the house rent. If you calculate the average expenditure, it comes out to be 1620 by the notion of mean and rupees 700 by employing the median concept. However, the median concept here is more efficient because the nature of the data is skewed and symmetric. Now, this is the third measure of central tendency, that is mode. The mode value which appears most often in the given data, that is, the observation with the highest frequency is called as mode. An easy way to remember mode is MODE, most often data entered. Now let us see how to find out mode for different kinds of data. For raw data, we just need to find out which observation is repeated maximum number of times. So we can see in the figure 9 number, which is shown by yellow color, is repeated 3 times. So therefore 9 number is repeated maximum number of times. Therefore mode of the corresponding data is 9. Now, the formula for continuous frequency distribution or for group frequency distribution. These are the certain steps involved in this. Find model class. Model class is the class having maximum frequency. And then use this formula to find out mode. So the formula is L plus Fm minus F1 upon 2Fm minus F1 minus F2 into H, where L is indicating lower limit of the model class, Fm is the frequency of model class, F1 is frequency of previous class of model class, F2 is the frequency of next class of model class, and H is the class width. So very important step to find out mode is that we have to find out model class first. So we can discuss in the example. So this is the frequency distribution, group frequency distribution with classes and the frequencies. So in this data, we can observe that the class 40 to 60 is having highest frequency, that is 12. So the corresponding So let us continue how to find out more for group frequency distribution. So the class 40 to 60 comes out to be model class. Therefore, lower limit of the class is 40, upper limit is 60. Frequency of the model class is 12. F1, that is frequency of previous class of model class, is 10. F2, frequency of next class of model class is 6. H is the class width, that is 20. Therefore, after putting all the values in the model formula, we have mode value as 45. Now, let's see when mode is preferred. Imagine that you live in a small town where most of the people are employed by a factory and earn minimum wage. One of the factory owners lives in the town and his salary is in the millions of dollars. If you use a measure like the average to try to compare salaries in the town as a whole, the owner's income would several throw off the numbers. This is where the measure of mode can be useful in the real world. It tells you what most of the pieces of data are doing within a set of information. Important note regarding this mode is a data may have no mode value, single mode value, or more than one mode value. Depending upon the number of modes, there are different types of data called unimodal, bimodal, trimodal, or multimodal. The example discussed here, they are showing about bimodal and trimodal. Yellow color in that list A is given. In that we can see that number 3 and number 4 are repeated 2 times. Therefore, it is having two values of mode. So therefore, it is called as bimodal data. In blue color, we can observe that list B. In list B, we observe that number 3, 4 and 5 repeated 2 times. So there are three different values of mode. Therefore, this data is called as trimodal data. Now we can visualize this mode by any picture also. We can see that in the given picture, different blocks are given, different color blocks are there, blue color, red color and yellow color. And we have to find out which is the modal color. So we can count number of blocks belong to particular color. So there are 4 blocks of blue color, 2 blocks of green color and total 5 blocks are of red color. So therefore modal color is red color in this case. Similarly, we can see next picture of histogram. In that case, we can see this green color is having highest height. Therefore, it is having highest bar. Therefore, green color is modal color in this picture. Applications of mode. Mode is used to decide which brand mobile is purchased. Most seller product is generally considered as a good product. If we need to find the most favorite subject of students in a given class, mode can be used. The mode may be beneficial for a manager of a shop store. For example, you would not see size 17 shoes stocked on the floor. This is why, because very few people have a size 70 shoe size. Therefore, store managers make look at data and determine which shoe size is sold the most. Managers would want to stock the floor with the best selling shoe size. Many decisions in day-to-day life is taken on model concept, like going to watch a movie where most people are going, or choosing color of car as the one most people are buying. A retailer may want to know the mode of sizes purchased of clothing by store to help them set stocking levels. Let's suppose store A has a mode of small size and store B has mode of double XL size. Now, this is the relation between mean, median and mode. That relation is called as empirical relation. Relation is mean minus mode is equals to 3 times mean minus median. This relation is applied when out of these three measures, one of the measure is unknown, then by using this empirical relation, we can find out the unknown measure of central tendency. So this is model number 1, which contains mean, median and mode. Hope you understand this. If you understand little part of it, please do fill feedback form whose link is provided over here. Also, I have prepared one quiz on this module, so try to attempt it also. So these are the corresponding links, feedback link and quiz link. Thank you.